Hello everyone, this is Maths Guy Channel here, and today we're going to be solving the hyperbola. Okay, so the first step we want to do is we need to talk about the maximum domain. It's sort of a trait that expresses the existence of the hyperbola. So it states that the values of x, so you can't have values of x that will make the denominator 0, or values of x that if something is divided by something else, like by a square root, the number inside the square root is a negative number, which is a bit hard to explain by if I type it up here. So if 1 over 0, obviously undefined, and 1 over the square root of negative 1. Square root of negative 1 is I, but for our purposes, it's undefined. It's not a real number. Okay, so now the hyperbola. So in the basic form is f of x equals x to negative 1, or 1 over x. And yeah, so this is what it looks like here, and there's a new term we have to learn about here, asymptotes. So here are these sort of lines that the function it approaches but never touches. So if you look in here, you can see that the function is getting closer and closer to the x-axis, but never touching. And the same way here with the y-axis. So for this function, what f of x is 1 over x, there is a vertical asymptote at x equals 0, and a horizontal asymptote at y equals 0. Quick refresher of domain and range. The domain is what the x values the function can take, and range is the same for the y. And both are real except 0, because you can't actually get 0 of either of these. So if we use the general form, a equals x minus h, a over x minus h plus k. Let's get rid of this, Okay. So k is your per usual up and down, nothing changes there. H is your side to side, nothing changed there. A is your dilation. When the dilation is negative, the graph flips. So when it's positive, it's in the quadrants here. So quick refresher of quadrants. So this is quadrant 1, 2, 3, and 4. So in normal hyperbola, it is in quadrants 1 and 3. But when it's flipped, when it's on the negative side, it flips. Well, okay, obviously when the thing is 0, you only have a straight line, hence the k, just the k value, and it flips like that. Okay. So yeah, you can generalize this with the vertical asymptote x equals h, the horizontal asymptote y equals k. The domain is real except all of h, and the range is real except all of k. So if you are given a hyperbola in the form of a equals bx plus c, and you want the vertical asymptote, because there's a b in the front, you have to do some manipulation, and you have to go solve bx plus c equals 0, and the domain would be r slash, you see, is real except negative c over b, is when you make x the subject as a result of this. When you have a hyperbola in the form of like something like this, so something divided by something else, it's gonna be a little trickier, but what you need to do is you have to change it to this rational form like this. So try to find like terms. So here 2x, we're gonna put, since the denominator is x plus 1, top part also has, you can also do it on the top part here. So you put x plus 1 here, like this. So these are two same things. So when you expand this, you get 2x plus 2 plus 3, so it's 2x plus 5, and then you split it like this, so that you, I think you can get it here. Then you cancel out the x plus 1 here, and you get 2 plus 3x plus 1, and all the previous steps will be the same there. Alright, and that'll be all.